Question number 20 deals with eye, human eye. What is range, sensitivity, limit of resolution? What are the various defects? And what is the remedy? What is the answer, solution to that? That is lenses. Point number 1 is range. Range for what? Normal eye. Freehand drawing, freehand. Normal eye can see an object clearly 25 centimeter to infinity. So field of view for a normal eye is 25 centimeter to infinity. This is the range in which if you place an object I can see. This is termed as near point. This point is termed as near point. This is termed as far point. 1 minute with you to write. 1 minute to write point number 1. So range is what? 25 centimeter to infinity. This is near point. This is far point. Point number 2. Limit of resolution. If there are two objects separated by distance h, they will subtend an angle theta at the eye. Suppose this distance is x. Minimum value of theta should be what? 1 minute. Two objects should subtend an angle more than 1 minute, then I can distinguish them as a separate. It can be two alphabets in your book. If you keep on moving the book away at certain distance, this theta becomes less than 1 minute, and you may not get these two separate images on your retina. 1 minute means what? 1 by 60 degree angle. But we write angle in terms of radian. SI unit for angle is radian. It is pi by 180 radian. So theta minimum 1 minute to write. To consolidate this, we take up one example. You can write the statement. Write down the statement. Two objects are at distance 11 kilometers from eye. Full stop. What should be the distance? What should be the distance between the two objects to be resolved, so that the objects can be resolved as separate objects? Tangent theta is equal to what? Tangent theta in this case. Yes, you can write h by 2, this angle is theta by 2. Directly you can write h by x. Angle is very, very small, 1 minute. Tangent theta is approximately equal to what? Theta, h by x. So h is equal to what? X into theta. This is what you need to find out. X is given how much? 11 kilometers. 11 into 10 to the power 3 meters. Do it. Find h. Calculation part, h is equal to x into theta. 11 into 10 to the power 3. Theta, yes, 1 by 60 pi by 180. 2 minutes for calculation. Approximately 3.2 meters. Point number 3, sensitivity. Human eye is not equally sensitive to all wavelengths. Sensitivity graph is human eye sensitivity along y-axis, wavelength along the x-axis. Yes. Yes, 4,000 to 7,000. 4,000 angstrom. This is 4,000 angstrom and color is violet. This is how it starts. And to 7,000 angstrom is red. At the central point, it is 5,500 angstrom. At this, it is maximum. Sensitivity is maximum. It is Vipagayor. It is green with yellow touch, or you can say yellow with the green touch. So, 1 minute to write sensitivity. Point number 4. It is first defect. Myopia. Short sightedness. 1 minute to go through the book what this defect is. Yes, what this defect is? Short-sighted means what? Person can see nearby objects. So suppose there is a defective eye, and for this person this near point remains as it is. How much? 25 centimeter or 0.25 meters. And suppose for this person this far point is not infinity but it shifts to say 100 meters. Suppose. So the problem with this person is the person can see only between 25 centimeter to 100 meters. You have to find power of lens to correct eyesight. One minute with you to first write this and then try. Concept formula 1 by V minus 1 by U is equal to 1 by F. No doubt we will place the lens in such a way that whatever was a shift in focus length, that I will give you the reason at the end. So now if there is any object at infinity, normal eye can see it large distance. But if for this particular person, defective eye, if the object is here, the person won't be able to see it clearly. So if there is object at infinity, it is not a problem for this person, normal eye, but for this person it is a problem. So object is at infinity. You need to make such arrangement, some lens here, such that the image, no doubt image is formed on retina, but it is a method to solve numericals that the image shifts to this position. That means what? Object, for this particular case, U is equal to what? Where is the object? Infinity. Where is the image? Minus 100 meter. You have to find out, first find focal length, then find power. Do it. If you put U is equal to minus infinity, 1 by infinity, this part is 0. 1 by V minus 100 minus 1 by minus infinity is equal to 1 by F. F comes out to be what? Minus 100 meter. Power is equal to 1 by F is equal to minus 0.01 what? Diopter. Negative sign means what? Diverging lens. That means if you place a diverging lens before the eye, the image on retina will shift in such a way that this is the behavior. This is what it is. Now we work out why it is so. Reason. What is the cause? Reason. For normal eye, if the rays are coming from infinity, I will explain reason in this part only. Rays are coming from infinity and they are focused at a retina. This is normal eye. What about this defective eye? Yes, for defective eye, Anyone? Yes. Refer to the book and just see where it is. It is not at a retina. It is easy way to remember short. So it is defective eye. Corrected. Technically you can say this lens becomes more powerful. Focal length decreases means power increases. So now what you need to do is you want to decrease its power. It is converging lens. You will have to place what? You will have to place a diverging lens. And what is the effect? Rays coming from infinity first diverge, then again after passing through the lens converge and they move to retina. And the image formation is at same point after you place this lens. So that means this lens is for what? Power adjustment. Combination of lenses. 1 minute with you to write reason. Defect 2. Yes. Hypermetropia. Point number is 5. Defect number 2. Hypermetropia or long-sightedness. First, what's wrong with this eye? Again, before you take into account a defective eye, we need to know normal eye can see object from 25 centimeter to infinity. So range for normal eye is 0 to infinity. For this person, yes, this fellow can see long distances, but nearby distances, there is a problem. This person will have a tendency, reading book at this distance, will shift it at a certain distance. That means what? This point, 25 centimeter, is not 25. So the field for this point is, its near point has shifted, say, from 25 to 50 centimeters. Again, problem is same, issue is same. You need to design specs for this fellow, and after that we will work out reason. Power of lens. For what purpose? To correct the eye. Problem is, if you place an object before the normal eye at 25 centimeter, normal eye will be able to see it. But for this person, this object is at 25 centimeter, but this person can see from 50 to infinity, cannot see this object at 25. So when you place this object 25, its image formation should be at 50. 1 minute with you to try. 1 minute to try. Draw the diagram. Concept to be used is same. 1 by V minus 1 by U is 1 by F. Yes. So the object is, you place this object at what distance? 25. But this fellow is unable to see that. That means object is at 25 centimeter and image formation is at 50 centimeter. U is equal to what? Minus 25. V is equal to what? Minus 50. You have to find out what? F. 1 by V minus 50 minus 1 by U minus 25 is equal to 1 by F. When you solve, F is equal to what? Plus 50 centimeter or 0.5 meter. This is focal length. Par is equal to 1 by F, 1 by 0.5 is equal to 2 plus 2. What? Units? Diopter. Unit is diopter. 1 minute to complete. Yes. Reason. Normal eye. Rays are coming from infinity. Focus is at retina. Defective eye. Yes. Help. Back side of retina. It will shift from this position to this one. Previous one, I have not drawn the diagram. Yes. Power was plus. So you place a converging lens. In the previous question, power was equal to what? Last one. Corrected eye. Number of questions in competition. If you are through this theory, you can answer all questions. What is the problem with this defective eye? Power of the lens has decreased. That is why you are placing one more lens to support the eye lens. That is. And again, the image formation is at retina. 2 minutes with you to write. Fact number 2, fact number 3, presbyopia. Go through the book, 1 minute. What is presbyopia? Yes, it is old age disease where the eye loses ability to accommodate, that is flexibility, and both near point and far point are shifted. For normal eye, yes, it is between 25 centimeter to infinity. For defective eye, this 25 centimeter may shift to say 50 centimeter. And this point is also not at infinity, say at 100 meters. So the range is less. So near point shifts from 25 to say 50, far from infinity to say 100 meter. What is the solution? Yes, combined solution of defect number 1 and defect number 2 means what? Both lenses, one converging and one diverging. This is defect number 3. Defect number 4, point number 7. Yes. Astigmatism. 1 minute to go through. 1 minute to go through. Reason, yes, eye can have different focal length along different axes. Along x-axis focal length is different, along y-axis it is different, or through this axis it is different, through this axis it is different. Eye has focal length different along different axes. So defective eye, if you place an object of this type, the image formed on retina may look like this. Because along this the focus length is different. This is the problem, that is defective eye. This is defective eye. What is the remedy? To have cylindrical lenses have different focal length along a different axis. This is corrected. Again the object, this is the object. In this case again the same object. You place what? In front of eye you place cylindrical lens in front of the eye. Then the image formed on retina is same as that of object, that is in the previous case this was the problem. If you place a cylindrical lens you can correct it along a different axis. 1 minute to note down. Refer to numericals. Page number 6 by 128, numerical number 1. Numerical number 1 is a short-sighted person cannot see clearly beyond 2 meters. Calculate power of the lens required to correct his eye to normal vision. So draw for normal, draw a diagram for normal, draw a diagram for this person also. Short-sighted cannot see beyond. So what is given is normal eye. Yes, 25 centimeter to infinity. Draw this. What about this defective eye? Yes, cannot see beyond 2 meters. So this is 25 centimeter or 0.25 meter. And far point for this fellow is 2 meters. This eye can see only 0.25 to 2 meters. We have to find out what. So given is what? Person cannot see beyond 2 meters. Concept 1 by V minus 1 by U is equal to 1 by F. Yes, what is the value for UV? Where to place the object? Yes. Yes, if you place an object at infinity, this normal eye can see, but this person cannot see. Why? Can see only between 0.25 to 2. So you place an object here, and where you want to shift its image to be? Somewhere where the eye can see. So that means what? U is equal to what? Yes, infinity or minus infinity. V is equal to what? Minus 2. Find F and power. For all these cases, when U is infinity, this part is 0. 1 by V minus 1 by infinity is 1 by F. F is equal to what? V. In this case is what? Minus 2. So focal length of the lens is minus 2. Power, yes. Point number 3. Power is equal to 1 by focal length is equal to 1 by minus 2 is minus 0.5 SI units diopter. Try numerical number 3. Numerical number 3 is a person cannot see the object distinctly when placed at a distance less than 100 centimeter. What is the power of spectacles that he should use to see clearly the object placed at 25 centimeter. This is normal eye. Can see from 25 to infinity. What about this person? Yes. Yes. Cannot see if the object is between 100 to I. That means what? This near point has shifted to what distance? 100 centimeter. And the range, this is the range for the person from 100 centimeter to infinity. So it is equivalent to what? If you place an object here, I can see, normal eye can see. What about this defective eye? This defective eye cannot see an object at 25 centimeter because this person can see only if it is placed from 100 centimeter to infinity. Equivalent. This is the equivalent treatment, that how the images will shift on retina. Actually, the image formation is on retina. But for calculation, it is one method. So, near point of defective eye is what? 100 centimeter. Solution, step number 1. 1 by V minus 1 by U is 1 by F. U is equal to what? Yes, minus 25 centimeter. V is equal to what? Minus 100 centimeter. You have to find out F and then power. Yes, put value for the same. 1 by V minus 100 minus 1 by minus 25 is equal to 1 by F. F is equal to what? 100 by 3 plus or minus centimeter plus 1 by 3 power is equal to 1 by F is equal to what? It is 1 by 3 meters. So 1 by 3 is equal to 3. Power is equal to plus 3. What? SI units? Diopter. So by placing a converging lens, you can do this.